So, hurricanes part two, I guess you could say, chapter five. So now that we know what causes them and where they happen, hurricanes are probably one of the most damaging things that happen to the planet, and worldwide they are one of the main killers when it comes to meteorological events. And it's not the wind. In a tornado, your greatest risk is the wind blowing something that would hurt you, like a car or something. But in hurricanes, it's flooding, it's water, and they call that a storm surge. So when hurricanes happen, when they come near land, right? If you're out in the middle of the ocean and a hurricane is blowing, it's dangerous because of the wind and the rain. But where the most loss of life happens is when hurricanes come ashore, because what happens is they basically cause a huge flood along the coast called a storm surge, and that the sea level basically just jumps up enough so that if you were living near the coast, if you're living in New York, like the movie that I have you watch, Hurricane Sandy, and sea level goes up by 5 feet because of the hurricane, that means that houses are flooded and people die. When you think about Hurricane Katrina in New Orleans, most people died of drowning from flooding. And storm surges are a combination of wind and air pressure. Storm surges cause the most deaths, and that is why in the Indian Ocean it is the greatest killer as well. Because of the physical geography, the landscape of the coast, it basically makes it worse. And you factor in the way people live, subsistence farming. We're going to get into that in a little bit. But let's talk about a storm surge. Here's a hurricane. It's going round and round, but it's generally moving towards shore. And as it moves this way, it pushes a big wall of water ahead of it, and that's the storm surge. And when this water hits land, it's going to flood it. Most of this is caused by the wind. Just like if you blow out a cup of water, the water all goes to that one side. A little bit of it is low pressure. Remember that hurricanes are extremely low pressure, so this almost acts like a vacuum. So right near the eye, it also pulls about 5% of it too. So we look at the 10 deadliest hurricanes that we know of. Obviously, hurricanes have happened throughout history, but since we've kept records. And you can see the deadliest hurricane, 500,000 dead, and this happens in the Indian Ocean, Bangladesh. This area right here in India, also in India, Bengal, Calcutta, Burma, Bangladesh, of the 9 deadliest hurricanes, only the one in Vietnam and here in China did not happen in the Indian Ocean. So you can see that by far and away the most deaths happen here. Okay. When we focus on the U.S., right, the deadliest one happened in Galveston, Texas in 1900. And that's simply because of the technology. In the 1900s, we didn't have satellite technology. So we didn't know a hurricane was coming unless someone at Ocean saw it and reported it in. But in the 1900s, we didn't have radio. So we didn't know a hurricane was coming until maybe 2 or 3 days before when we saw the clouds on the horizon. So there was no time to evacuate. Normally, by that time, when a hurricane hit, it was upon you. Now, Galveston, Texas, is a city that is on an island right off the coast of the ocean. It's on the Gulf of Mexico. And the island is only 2 or 3 feet higher than the sea. So enough that you're dry, but if a storm surge comes in, and that's what happened, Galveston was flooded with, I believe, a 10-foot storm surge. So basically the entire island was under 10 feet of water, and no one evacuated. That's why. You look at Hurricane Katrina, very similar. Most of New Orleans is actually built on land that is below the level of the ocean. We have big, huge earthen walls to keep it out. And so if the hurricane hit, and when it did, it flooded the city. That's why the death toll is so large. Scientists have been saying for years that New Orleans was a disaster waiting to happen for the fact that it is this basically city that is surrounded by water, but it's underneath that level. And all it takes is a storm big enough to hit it dead on, which is exactly what happened. So let's move on to a mid-latitude cyclone. Not as exciting as a hurricane, but also a very large storm. And these happen in a lot of similar ways. It's the mixture of warm and cold air. Now, a mid-latitude cyclone still is a cyclonic storm like a hurricane. It's just not as tightly coiled. It's much larger. But this involves two bodies of air meeting, warm air and cold air. So when a body of air is warmer than the body of air next to it, it's called a warm air. When they hit, okay, if the cold air is stationary and the warm air hits it, that's called a warm front. if the warm air is just sitting there and cold air plows into it, that's a cold front. Okay? So when you hear the weather forecast and they say there's a cold front moving through, that means that some cold air is coming from somewhere else over warmer air. It doesn't mean the air is cold. It just means that the air is colder than the air that's coming in. Here's an example on a map. Right here is an area of low pressure. Okay? Wind on this side of it that wants to blow around it, right? This is cooler air than the air here. It's not that this air is cold and this is hot, but at this point and this point, same distance north or south, same altitude, this air is going to be warmer. So cold air, this is a cold front. This right here is a warm front. This air is warmer than this air and is pushing this way. So you've got three bodies of air, a cold body of air, a warm body of air, and another cold body of air. And this right here, this movement, causes a storm. Along this line and along this line, you're going to have storms and clouds. If you look at it from Earth, from a satellite, you can kind of see here's the cold front right here. And then if you look at that, you can't really see it, but here all these spiral bands are different arms. So what does this do? Well, we have these type of storms usually fall through spring in the United States, and if they're warm fronts coming in, so let's go back. So along this line, we're going to see one type of rainfall pattern, and along a cold front, we're going to see another one. A warm front, you generally see nimbostratus clouds that have steady rain. Not hard rain, but steady. So like it rains for 2 days straight. That's a warm front coming through. A cold front has cumulonimbus clouds, the big, huge, puffy clouds, the big, huge, multi-cell thunderstorms that can produce sometimes rainfall or potentially hazardous weather. So here is a warm front. This is the cold air, it's stationary, and this warm air is coming through. And as it happens, when they meet, right, the warm air rises, so it basically slides up over the cool air. So what happens is this warm, moist air slides over the cool air gradually. As it goes up in altitude, it cools off itself and begins to rain. So you have this steady, long rain form. And this just moves through. If you look at a map, it'll be like this. Cold front's a little different. Now here, you have warm air. Warmer than here. And because this air is just sitting here, when the cold air hits it, it basically acts like a plow. So notice here that it forces that warm air to rise over it, but at a much shallower angle. It's almost like a plow going through. And it pushes this warm air up very quickly, which allows for these big, large rain clouds. And the higher this warm air gets pushed up, the stronger cooling energy cools it into rain, so you have stronger storms. So let me show you by comparison, right? These are weaker, widespread storms. A cold front produces strong storms. So this is when we get those huge thunderstorms. Now, these mid-latitude cyclones can actually have basically weeks of rain. So we'll have a week where we have really, really, really long rain, a warm front coming through, and the next week we have a cold front. They're all part of that same cyclone. They can take 2 to 3 weeks to go. And they usually come across the country. They'll start off in the Pacific Ocean, and they'll just go right across the country. Sometimes in the winter these happen, they create blizzards. And if they happen over the Great Lakes, they can make lake effect snow, which we'll talk about in a little bit. And a special name for one is a nor'easter. These are ones that happen in New England. And when they happen in New England, a nor'easter is a specific type of mid-latitude cyclone that creates blizzards. So here's what happens. You have a stationary front, right, but you have air coming in over the ocean. When that air coming in over the water hits the air over land, you have a difference in warm and a difference in humidity. And you start seeing these warm fronts and these cyclones form. And they move across the country. And so it takes maybe 2-3 weeks. Eventually it gets back over the ocean, and you don't have that difference in warm or cool air. It's the same moisture, and they break apart. And so they form these different ones. So here you have a cold front. Here you have a warm front. You've got different types of cyclonic flows. Don't need to know too much about this. Just know that these are the things that are the same kind of pattern with cyclones as a hurricane, but they create regular rain and blizzards. Pause here, and we'll come back with El Nino.